So now I am sharing my screen. You can see this clearly, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, fine.
Yes, sir.
In this section 2.5, we are going to deal with factorization of polynomials. And in order to do that, I will tell you what all things we are doing in this section. First of all, we will learn a new method for the factorization of polynomials, and we will use that to factorize polynomials using two methods. We will learn each and every method separately. And first, in order to do that, first of all, we have to learn this factor theorem. Factor theorem. This one. So I will explain it each and every word to you. You should be very careful and attentive in the class, because this theorem can be asked in your exams. It's important theorem. Moreover, we need this theorem. I mean, the result of this theorem to solve our problems. And in higher classes, which means from class 10, 11, 12, also you will need this. I mean, this section. I mean, the factorization of polynomials or the solving of these polynomials are necessary. So this is the basic class. You will need it to higher class. So if there is any doubt, you can ask me. Moreover, you should be very much careful and attentive in the class. So let us start. What does the factor theorem states? It states that if p of x is a polynomial of degree n greater than 1 and a is any real number, then we can infer two things. What are they? I'll say if p of a is equal to 0. If p of a is equal to 0. You know what does p of a means? It means nothing that we are substituting the value a instead of x in the polynomial p of x. And if we get the value of that polynomial as 0, then we can say that x minus a is a factor of that polynomial. That was the first condition. And the second inferring is, if actually this is the converse of the first statement, if x minus a is a factor of p of x, you know, that what do you mean by a factor of p of x or factor of any number? We can say that a factor of any number or any polynomial means it divides that polynomial or number completely. I'll show you. See, here we are taking the number 15. We can write as 15 is equal to 3 into 5. So we can say that actually number 5 is a factor of 15. It was a specific, just an example was taken. Okay. Now let us go. We are given if x minus a is a factor of p of x, then p of a is equal to 0. We are going to prove this, and in order to prove this, we need the help of remainder theorem, which you have just learned in the section 2.4. Nothing there is. The remainder theorem states that p of x is equal to x minus a into q of x plus p of a. It just states that only. Okay. So now we are going to prove it. See, when p of x is divided by x minus a, okay, when the polynomial p of x is divided by a factor x minus a, then the remainder is r is equal to p of a. This is what the remainder theorem states. So what we can write? We can write p of x is equal to x minus a into the quotient q of x plus the remainder, which is p of a. We can write like this from the remainder theorem. That is, dividend is equal to divisor into quotient plus remainder. Okay, this is using division algorithm. But what is given in the first section? It states that, I will use another color. It states that p of a is 0. So we are given that p of a is 0. See, so what happens in this area when p of a is 0? We can neglect that part. So what is the remaining portion? The remaining portion is only this much. P of x is equal to x minus a into q of x. Okay. See, that is what we have written here. P of x equal to x minus a into q of x. And what does it mean? It means that a polynomial p of x is equal to the product of two other polynomials, x minus a into q of x. Which means what? In the example that I have just shown to you earlier, number 15 is equal to 3 into 5. So we can clearly say that 3 and 5 are the factors of 15. Similarly, since we got p of x is equal to x minus a into q of x, it means that x minus a, the polynomial x minus a, is a factor of p of x. Thus, we have proved the first case. Is this clear to you?
Yes, sir.
Yes, sir.
Yes,
Okay. So now in a similar manner, we are going to our next section. In the next section, what it is given? It is given that the first section is if x minus a is a factor of p of x, that is given to you. See, given that x minus a is a factor of x, then we want to prove what? P of a is equal to 0. That's what we want to prove. So given that p of x equal to x minus a into q of x plus r, that is x minus a is a fact, it is given to you. Now if x minus a is a factor, then what we can infer from that? It means the polynomial x minus a completely divides the polynomial p of x. That is, there is no remainder. In other words, the remainder should be 0. Right? So by a remainder theorem, what you can say? By remainder theorem, we can say that r is equal to p of a, and p of a should be, in other words, the remainder should be 0. Actually, that is what we want to prove in the second case also. Okay. Am I clear to you?
Yes, sir.
yes, sir.
Yes.
This is an important theorem. That's why I am asking you many times, do you follow me like that? If anybody is facing any doubt, you can ask me, because we need this theorem to solve the following examples, the following problems. All of you, and are all of you clear with this theorem?
Yes.
Yes,
Okay. If anybody face any difficulty or any doubt, they can either message me or just talk to me. Unmute yourself and you can talk. And I remind you one more thing. If you are asked to prove factor theorem for in the section C or section 4, then you should write the remainder theorem also. Okay. You are asked factor theorem to prove. We know that we need this remainder theorem to prove factor theorem. Just don't write like this. By remainder theorem, we know this. Just state that theorem. Okay. By remainder theorem, what is remainder theorem? Just state it in an inverted commas. Okay. Then you should go further and prove it. This is how you may lose marks also. Sometimes you may think, I have proved the factor theorem and I will go score full mark. But the problem is you may not have proved or written this remainder theorem. That's how you are losing marks. Okay, keep this in mind also. Now we are going to use the help of factor theorem to solve for the following question. An example is shown to you. Okay. I'm going to solve. If anybody having any doubt or anything you want clarity, shall I go to next the question?
Yes, sir.
Yes, sir.
Okay.
Yes.
Now the question
Yes,
is, okay, fine. Now question is, examine whether x plus 2 is a factor of x cube plus 3x squared plus 5x plus 6 and of 2x plus 4. You are asked whether the polynomial x plus 2 is a factor of two polynomials. This is a polynomial and again this is also a polynomial. We are asked to check whether x plus 2 is a factor of these two polynomials. So let us see. Whenever you are given this kind of question, first of all you have to find the zero of that factor. You know that what is the zero of that factor, right? How do we got that the zero of x plus 2 is minus 2? How do we got that?
X plus 2 equal to 0. Putting
Very good.
First and
Very
minus
good.
2 is 0.
Very good. Very good. So x plus 2 is equal to 0. Thus it means x equal to minus 2. So thus we have concluded the zero of x plus 2 is minus 2. Now you got the zero of the factor as minus 2. Now we are naming these two polynomials. These two polynomials as p of x and s of x. P of x equal to x cube plus 3x squared plus 5x plus 6, and similarly s of x is equal to 2x plus 4. Clear? Now what we are going to do? We are going to substitute the value minus 2 instead of x in the first polynomial p of x. Clear? So everywhere, wherever you see x, you can write there minus 2. Okay. So what do we get? P of minus 2 is equal to minus 2 cube into 3 into minus 2 whole squared plus 5 into minus 2 plus 6. So when we solve that, we get P of minus 2 is equal to 0. So by factor theorem, what we can infer? Factor theorem says that if P of A is 0, then x minus A. I'll show you once again. If P of A is 0, then x minus A is a factor of P of X. Now what we got? We got P of minus 2 is equal to 0. It means x plus 2 is a factor of the first polynomial P of X. Clear?
Yes.
yes, sir.
Yes,
Okay.
sir.
So
yes,
we have proved or we have checked that x plus 2 is a factor of x squared plus 3x squared plus 5x plus 6. Similarly, the same manner we are going to check whether x plus 2 is a factor of the second polynomial s of x is equal to 2x plus 4. See here, in the same manner, instead of x, you are substituting minus 2. So s of minus 2 is equal to 2 into minus 2 plus 4, which is equal to 0. Again, same manner, x plus 2 is a factor of 2x plus 4. Clear? There is no explanation is needed, I think.
Yes, sir.
Yes, sir.
Okay. And one more thing you can just for your knowledge, it can be seen that what is actually 2x plus 4? 2x plus 4 is actually 2 into x plus 2. So in that manner itself, you can easily find out that x plus 2 is a factor of 2x plus 4. That can also be used. Okay. And the proper way of solving these kinds of problems are this one. First of all, we have to find the 0 of the factor. Then we should substitute that value instead of x or instead of any variable. Then we have to check whether that p of that number or p of that 0 of the polynomial is 0. If it is equal to 0, then you can conclude that that polynomial is a factor of given polynomial. So you can take lecture notes also. I will send this to you after the class. Okay. So before that, if you want to take any lecture notes, you can write it also.
Okay, sir.
Okay, sir.
Okay, sir.
Now, shall I go to the next question?
Yes, sir.
Yes,
Yes.
yes, sir.
Yes, sir.
Yes, sir.
Actually, in mathematics, you may think that not just thinking, you know that each and every question should be solved in a different way. So, but the underlying key concept is same for each and every problem. In this section, the next example is a slight different example, but no problem at all. The key concept or the underlying concept is same for both these questions. Okay, so let us see. Here you are asked, find the value of k if the condition is given. If x minus 1 is a factor of a polynomial is given, 4x cubed plus 3x squared minus 4x plus k. So here k means a constant. Okay. Now we want to find the value of k. And what information is given to you? You are given an information that x minus 1 is a factor. So we have to use, sorry?
Value of k will be minus 3.
Okay. That's you may know that some of you may have already
Value
learned
of
that. Okay, and those students who have found out already, they can just keep it them with you. Let others also learn that. Okay, no problem. So let us continue. We are given the information that x minus 1 is a factor. So x minus 1 is a factor of p of x. We are naming this polynomial as p of x from this. Using the factor theorem, what we can say? What does the factor theorem states that if x minus a is a factor of p of x, then what we can say? P
x is
of,
equal to 1.
let us see, p of a is equal to 0. You are given this in the factor theorem. See, now we are given that x minus 1 is a factor of p of x, which means p of 1 should be 0 by factor theorem. Okay. So we are going to substitute the value 1 instead of x in the polynomial p of x. So now look here, p of 1 is equal to, instead of x, we are substituting 1. 4 into 1 cube plus 3 into 1 squared minus 4 into 1 plus k. Now say 4 into 1 means 4. 4 plus 3 minus 4 plus k is equal to 0. And this plus 4 and minus 4 gets cancelled. So k is equal to minus 3. So the value of k we have found out. Am I clear to you?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Does any of you face any difficulty in solving these kinds of problem?
No, sir.
No, sir.
No, sir.
Okay.
No, sir.
And the next, I think the next section is it's an important section also. By splitting the middle term, it's an important section. Okay, because for your exams, you may be asked specifically that you have to factorize a polynomial. A polynomial will be given to you by splitting the middle term. It will be specifically told to you, use the method of splitting the middle term. This will be specifically told to you. So this is an important method also, important way also. So are you ready? We can go and learn that method also. Or
Yes. Yes, sir.
okay, very good. So let us go. We are assuming that the factors of this polynomial ax squared plus bx plus c as px plus q and rx plus s. We are assuming these are the factors of, okay, p of x plus q and r of x plus s. Okay, so what we can write? We can write x squared plus bx plus c is equal to px plus q into rx plus s. And again, we are multiplying it. So how we are multiplying it? First, we are multiplying like this, p of x, sorry, px into r of x. Okay, I will just rub this. We are multiplying like this. We'll use another color. P of x into r of x, which means, sorry, px into rx, which means p that is being multiplied. Again, the plus sign is used, px into s, and again we are multiplying like this, q into r of x and q into s. So we get that pr x squared plus, I will show you. What do you mean by px into s? We get that px s plus qrx equals, we can take x common, right? Am I clear to you? We are
Yes,
taking
Yes, sir.
x common from it and we are writing px plus, sorry, ps. One person is trying to enter our class, that's why these problems are. So this is clear to you. We have just skipped that step and pr, sorry,
You have split this in that equation one form, x square plus a plus b x plus ab, that equation form.
yes, that equation form is actually used. I just explained, showed it to you. For those students who may not have studied that part, they can use this section to learn that also. That's why I explained it. So we get that PR x squared plus PS plus QR into x plus QS. Now what we are doing? Now listen. Again, this is an important part. See, now we are comparing this equation and this equation. Let us see. We are comparing the coefficients of x squared. The coefficient of x squared in this equation is PR. Similarly, the coefficient of x squared is here is A. So we are writing A is equal to PR. Similarly, we are taking the coefficient of x also. Clear? Coefficient of x will be B is equal to PS plus QR. Now again, we are comparing the constant terms. That is C is equal to QS. Okay. Now, from this information, what we have understand? We understand that the middle term or the coefficient of x, it is actually the middle term. That's why we are calling this method as splitting the middle term. So B, the middle term, is the sum of two numbers, PS and QR. Again, we are, say suppose we are multiplying these two numbers, PS and QR. See, look here. We are multiplying PS and QR. We are writing P and R together, Q and S together. So what does it mean? Actually, what is PR? PR is A. So instead of PR, we can write A, and instead of QS, we can write C. So what we can found out, what we have just found out, we have found out that in order to factorize a polynomial x squared plus bx plus c, we have to write the middle term b. What is the peculiarity of writing the middle term? It should be written as the sum of two numbers whose product is AC. AC means the product of coefficient of x squared and the constant. I know that some of you may find it difficult, but no problem. When you do an example, it will be clear to you. So I am just showing the method why we are doing so. Okay, so again let me tell you, by splitting the middle term means we are using the middle term b. In other words, the coefficient of x. We are splitting the middle term b, and we are using that the splitted middle term to solve or factorize the polynomial. In other words, we should find two numbers. Two numbers is not necessary, two factors, such a way that the sum should be b, and the product of that two numbers should be A into C. Clear? This is the method of splitting the middle term. Am I clear to you?
Yes, sir. Yes, sir.
And okay, very good. Now, what all things have we learned today? We have learned the factorization of polynomials. This is the section, and in this section we have just seen a factor theorem is shown to you or proved to you. What does the factor theorem says? It states if p of x is a polynomial of degree n greater than 1 and a is any real number, then we can say that x minus a is a factor of p of x if p of a is equal to 0, and again p of a is equal to 0 if x minus a is a factor of p of x. We have proved that, and we have used this factor theorem to solve the questions. Some questions was given to you, and again we are using the in the same manner we have solved two questions, and now we have learned the factorization of polynomials by splitting the middle term. The method was shown, and in our next class we will be using this method and the factor theorem to solve or to factorize polynomials. So you should learn these methods clearly. Okay, am
Okay,
I
sir.
clear to you?
Okay, sir.
Okay, sir.
Okay, sir.
Yes, sir.
And if anybody is having any doubts, you can ask me now. We are running out of time.
Sir, you said this recording screen in the WhatsApp group. That means we have to write the notes of this that you sent.
I don't understand. I will record this video and upload it in YouTube, and I am creating a playlist. I will send to you, not today like that. Before exam, I will send the link, and the notes will be given to you now itself. This PDF will be given to you. All of you should write the notes in your maths copy book. Clear?
Okay.
अगली बार में क्या मतलब हुआ?
So is there any doubt? You can ask me now.
20 रुपए की बात है. चलो.
Is there any doubt? Anyone? Or else we can wind up the class.
No doubt, sir.
No doubt, sir. No doubt.
No doubt, sir.
No doubt, sir.
Okay.
No doubt, sir.
Okay.
No doubt, sir.
Okay. And from our next class, we will be solving problems using these two methods. Okay. So there is nothing. Let us stop. Thank you.
Thank you, sir.
Thank
you,
you,
sir.
sir. Thank you, sir.
Okay.
Thank you, sir.
I'm ending.